In this video, we're going to take a look at finding the derivative of an implicit function. And an implicit function will look something like this. 3x squared plus 5y squared plus 2x minus 10 equals 0. And it doesn't have to be an equals 0 on that side. We could have other terms involving x and y over there as well. But notice that this function is not solved for y, as you're probably used to. You're probably used to seeing things like y equals 6x squared plus 3, right? This is an explicit function, explicitly solved for y. And we have found ways of finding the derivative of those so far. Now, rather than rearranging this equation so that it is solved for y, which is sometimes very difficult to do, we need to find a way to find the derivative without solving for y first, and that is leaving it in its implicit form. And so to do this, we're going to do this by differentiating each term of the implicit function with respect to x, even those terms that are in y. That means that every time you differentiate a function in y, you will introduce the dy by dx factor. And after doing that, you will isolate the dy by dx to find the derivative. So let's take a look at an example. I'm going to show it with two different notations, and you can choose whichever one you find to be best for you. Okay, so for this function, there it is. We want to recognize that we have different terms, some in x, some in y, some constants, and we want to differentiate each term with respect to x and take a look at that. So let's introduce the dy by dx notation. We're going to the derivative of 3x squared with respect to x plus the derivative of 5y squared with respect to x. That one will be different. Plus the derivative of 2x with respect to x minus the derivative of 10 with respect to x equals the derivative of 0 with respect to x. Now, some of these you already know. It's just a notation that's different. So this is our function 3x squared. We are differentiating with respect to x. If that was just a single term, we would just apply the exponent rule that we saw. We multiply the 2 by the 3. All right, and we get 6x, and then we reduce the exponent on 2 by 1, down to 1. I'll write the 1 just for now. That was a term in x differentiated with respect to x, so we can leave it just like that. Now I'm going to skip over this next one for just a moment, and we'll do this next one that's also in terms of x. What's the derivative of this? We have an exponent 1, it's multiplied by 2, and then now it becomes x to the 0, and x to the 0 is just a 1. That's in terms of x, so we do not need to do anything else. How about the derivative of this constant with respect to x? Well, the derivative of a constant is 0. Equals, and this one is a constant as well, okay? So that's a constant, and that's a constant. Their derivatives are 0. So those things are really just repeats of what we've seen before. It's this part in here that is something new, all right? We're differentiating a term that has a variable that is y, but with respect to x. We're looking at this as a differentiable function of x. And so what we need to remember, we're going to still apply the same property. So I'll multiply the 2 by the 5, 10, y, keep the variable. We will reduce the exponent by 1. It'll be 1, but we have to introduce the dy by dx factor. Okay? In fact, let's put that in red for now. dy by dx. Okay. And so then my notes up here said, after we do that, we need to isolate dy by dx. So this is a product right here. We will leave that term as it is, and all of the other terms are going to go to the other side of the equal sign. And so we'll leave our 10y times, let's keep it in red to make it really stand out. And we'll say equals, I'm moving my 6x to the other side, it will be minus 6x. And I'm moving my plus 2 to the other side, it will be minus 2. And we're still working on isolating the dy by dx, and it's multiplied by 10y. So in order to isolate it, I need to divide both sides by 10y. Okay, so dy by dx equals minus 6x minus 2 over 10y. If you want to reduce, each of those is divisible by 2. You could do that. You might want to turn the negatives out, bring the negative out, but you know what? You can just leave it like that. Okay, so that's what needs to happen. Let's just take a look at a slightly different notation that doesn't involve all these dy by dx's in here, just so that you can simplify what you're writing. Okay, so I'm going to do the same one, just with a slightly different notation. So what did we have? We have 3x squared plus 5y squared plus 2x minus 10 equals 0. I think it was a minus 10. We better make it the same. Yes, okay, that's the same function. Now, a short way to do it is just to, every time we are dealing with a term that's not an x, we multiply that derivative by y prime. So I'm just going to look at each term, take its derivative. This will become 6x. Look at this term. Take its derivative as if this is an x, right? But it's not. So it's 10y. It's not an x, so we will multiply by y prime. Then we move to the next term. Differentiate it with respect to x. It's just a 2 minus 0 equals 0. Okay. It's a little bit shorter notation. So in other words, anytime you are taking a derivative of a term that is not an x, you need to multiply by y prime. Now we will isolate the term with y prime. And divide out to isolate y prime. Okay? There. All right, so I want to show one more example that involves the product rule. So let's look at another one. Let's do 4x cubed plus 2xy squared plus 5y equals 12. All right. So we have this term is just in x, so that will be pretty straightforward. This term is just in y, so it's just going to be similar to the one we did in the one above. This is a constant, so that derivative will be 0. But right here, we have a product of two different functions of x, okay? So the x is a function of x, and the y squared is considered to be a function of x. We have a factor of 2 in front, so what I often do is I just attach the 2 to the first factor, and I kind of split it here for my product rule. So remember, the product rule is that we have to multiply the first term by, or the first factor by the derivative of the second, and then the second factor by the derivative of the first. So we're going to still do that using the same notation, and I'm going to use that y prime notation. Okay, so y prime notation. All right, let's take a look at that. So the derivative of the first term, 3 times 4 is 12x squared. It's already an x, no need to multiply by y prime. Plus, now I'm going to bracket this just to have it separate from everything else. Product rule right here. So this is my u and this is my v. So for the product rule, we have to multiply u times the derivative of v. So I want to multiply 2x multiplied by the derivative of y squared. Well, that will be 2y. And because it's not an x, I must multiply by y prime. So that is u times dv dx, right, for the product rule. And then we're going to add to that v, that's y squared, multiplied by the derivative of u. And the derivative of u, that's the derivative of 2x, is just 2. Do I need to multiply by y prime? No, not for this one, because we didn't do the derivative here. We just left it as v. And the derivative of the u, well, that was already in terms of x. So we don't need to. So this is v times du dx. And let's end that one. So that just separates. All right, that took care of all of that. And now we have to move on to the plus 5y. The derivative of that is plus 5. But because it's a y, not an x, we must multiply by y prime. And then the derivative of 12 is 0. Okay. Let's just tidy this up now. We have, get the brackets out there. So we have 12x squared plus, okay, multiply 2 times 2, which is 4xy. I'll still do my y primes in red. Plus, and normally, we'll just bring this 2 in front, so that's a 2y squared plus 5y prime equals 0. All right. We want to isolate for y prime. Okay, so isolate, oh, let's do that in another color. Isolate y prime. So I'm going to leave the terms with y prime on the left for now. Leave the y prime terms on the left. All the others to the right. Okay, let's take a look at that. So 4xy times y prime plus 5 times y prime equals, now I have to move the 12x squared to the other side is minus 12x squared. And we're moving the 2y squared as a minus 2y squared. And that's everything. Now, remember, we still want to isolate y prime. Y prime, right here, y prime is a common factor. That's why we left those terms together. factor it out. Okay, so y prime multiplied by, well, if I factor it from the first term, I'm left with 4xy, and I factor it from the second term, I'm left with 5, not the second term, and that's factored out. Let's leave our minus 12x squared and our minus 2y squared like that. And now to isolate y prime, I just need to divide by everything that's in the brackets here. Okay, y prime is equal to minus 12x squared minus 2y squared all over 4xy plus 5. All right. No need to, I mean, if you see an obvious common factor that you want to take out, that's fine, but there isn't one here, so we'll just leave it. And y prime is the derivative. Okay, that is all I want to say about those right now. This was derivatives of implicit functions. Thank you for watching.